Ever wondered how your smartphone predicts your next word or how your email filters out spam? The answer lies in the extraordinary intersection of two fascinating fields: artificial intelligence and machine learning. Artificial intelligence, or AI as it's commonly known, is a broad field that focuses on creating machines that mimic human intelligence. It's about building smart systems that can understand, learn, and act. It's the brains behind your digital assistant, the eyes of a self-driving car, and the heart of a recommendation system that suggests your next favorite song or movie. On the other hand, machine learning, a subset of AI, is the method by which we teach these machines to learn from data. It's the process of feeding an algorithm tons of data, allowing it to learn patterns, make predictions, and improve over time. It's the magic that enables your email to distinguish a genuine message from a spam, or your smartphone to predict your next word as you type. The relationship between AI and machine learning is symbiotic. Machine learning provides the learning capabilities to AI, and AI provides the smart framework within which machine learning operates. Together, they form the backbone of intelligent systems that are becoming increasingly prevalent in our everyday lives. From speech recognition in our smartphones to product recommendations on e-commerce websites, from personalized content on social media to predictive text in email applications, from traffic predictions in navigation apps to disease detection in healthcare, the applications of AI and machine learning are wide-ranging and ever-growing. They are silently revolutionizing the way we live, work, and interact. So, the next time your smartphone predicts your next word or your email filters out a spam, you know it's not just a technological gimmick, it's a testament to the incredible power and potential of AI and machine learning. These are just a few examples of how AI and machine learning influence our daily lives. Machine learning, a term that sounds complex, isn't it? Well, let's break it down together. Imagine a toddler learning to identify a cat. They don't instantly know what a cat is, but through repeated exposure to different cats, they begin to recognize common features: fur, whiskers, a tail. Over time, they can confidently point out a cat, even if they've never seen that particular cat before. This is similar to how machine learning works. Machine learning is a subfield of artificial intelligence that gives machines the ability to learn from data without being explicitly programmed. It's like providing these machines with a learning ability, a little like our toddler. The machines, or more precisely, the algorithms, learn from the data they ingest, identify patterns, and make decisions or predictions based on those patterns. Consider this: you're giving a computer a lot of images, some of cats, some of dogs. Each image is labeled whether it's a cat or a dog. This is your data. The computer, through a machine learning algorithm, studies these images, recognizes the features that distinguish a cat from a dog, and eventually, it can identify whether a new image is of a cat or a dog. This, my friends, is the magic of machine learning. But it's not all about recognizing cats and dogs. Machine learning powers many of the services we use today. It's behind the recommendations you see on your favorite streaming service, the voice recognition in your smartphone, the personalized ads on your social media feeds, and even the detection of fraudulent activities in your bank transactions. So, it's not as complex as it sounds, right? It's just about teaching computers to find patterns in data and use these patterns to make decisions or predictions. It's about giving them the ability to learn from experience, much like how humans do. In essence, machine learning is all about teaching computers to learn from experience. Imagine a toddler learning to identify animals. This is similar to how supervised learning works in AI. Supervised learning, as the name suggests, is a type of machine learning where the model is given a supervisor or a teacher. Think of it this way: when a child is learning to identify animals, they don't just magically know what a cat or a dog is. They have a guide, usually a parent or a teacher, who points to a picture of a cat and says, "This is a cat." Over time, with enough examples and repetition, the child starts to recognize cats on their own. Now let's translate that to the world of AI. In supervised learning, the model is provided with a set of input-output pairs, also known as training data. The teacher in this scenario is the algorithm that adjusts the model's parameters to minimize the difference between the model's predictions and the actual output. Just like the child learning to identify animals, the model learns from these examples and eventually can make predictions or decisions without being explicitly programmed to perform the task. Let's consider a practical example. Suppose we want to create a spam filter for email. We would first provide the model with many example emails, each one labeled as spam or not spam. The model would then learn the patterns associated with spam emails and apply this knowledge to new unseen emails to classify them correctly. Supervised learning is a powerful tool in AI and is widely used in various applications, including image recognition, speech recognition, and even self-driving cars. These models continuously learn and improve, becoming more accurate as they are exposed to more and more data. However, it's important to remember that the quality of the supervision significantly impacts the model's learning. If the training data is inaccurate or biased, the model will also be inaccurate or biased. Just as children learn with guidance, computers also learn with supervision. What if there's no teacher? Can a machine still learn? Welcome to the fascinating world of unsupervised learning, where machines learn without the need for explicit instructions or labeled data. It's like giving a child a puzzle and letting them figure it out without any guidance. Sounds pretty challenging, right? In unsupervised learning, the algorithm is presented with a dataset and tasked to discover hidden patterns or structures within it. The machine is like a detective, sifting through data, looking for clues and connections that can help it understand the underlying structure. It's all about finding relationships between variables and grouping similar data together. Imagine you've got a basket full of fruits, but they're all mixed up. An unsupervised learning algorithm could sort these fruits based on their features like size, color, and shape. It might not know that an apple is called an apple, but it can recognize that all these round red objects are similar and thus belong together. That's the beauty of unsupervised learning. It can make sense of the world without being explicitly told how to do so. This concept is vital in many real-world applications. Unsupervised learning algorithms help in discovering patterns in customer buying behaviors, detecting anomalies in network traffic, organizing large datasets, and even in genome sequencing. Two main techniques used in unsupervised learning are clustering and dimensionality reduction. Clustering involves grouping similar data together, much like the fruit example we talked about earlier. Dimensionality reduction, on the other hand, simplifies the data without losing important features or relationships. This is like creating a map from a three-dimensional world. The map is a simpler two-dimensional representation, but it still accurately represents the landscape. So, despite the absence of a teacher, machines can still learn through unsupervised learning. They can identify patterns, group similar data, and simplify complex data sets, all on their own. This is a testament to the power of machine learning and its potential in transforming technology as we know it. Without a guide, machines can still learn and make sense of the world. Ever watched a puppy learn a new trick with rewards and punishments? Well, that's pretty much the gist of reinforcement learning. It's a type of machine learning where an agent learns to behave in an environment by performing actions and seeing the results. Let's imagine a robot in a maze. The robot doesn't know the layout of the maze, nor does it have a map. Its goal is to find the exit. So it starts exploring, bumping into walls, taking wrong turns, but slowly learning from its mistakes. Each time it hits a wall, it gets a negative reward or penalty. And each time it moves closer to the exit, it earns a positive reward. This is the heart of reinforcement learning, learning through trial and error. The agent takes an action, the environment responds, and the agent adjusts its behavior based on the reward or punishment it receives. Over time, the agent learns to make better decisions, optimizing its actions to maximize the total reward. It's important to note that the agent doesn't just consider the immediate reward, but also the potential future rewards. This concept, known as the trade-off between exploration and exploitation, is crucial in reinforcement learning. The agent must balance the desire to make the best decision based on current knowledge, exploitation, and the need to gather more information to make better decisions in the future, exploration. Reinforcement learning is particularly useful in situations where we have a clear goal, but no clear path to achieve it. It's used in various fields, from robotics and gaming to healthcare and finance. For instance, Google's DeepMind used reinforcement learning to train its AlphaGo program, which famously defeated the world champion in the game of Go. So, when you see a machine master a complex task, remember, it's not just following a set of pre-programmed instructions. It's learning, experimenting, making mistakes, and improving, much like a puppy learning a new trick. Much like training a pet, machines learn through rewards and penalties. How does the human brain inspire machine learning? This question takes us into the fascinating realm of neural networks, an essential component of machine learning. The human brain, with its billions of interconnecting neurons, is a marvel of nature. It processes information, learns from experiences, solves complex problems, and even dreams. It's this intricate organ that serves as the blueprint for neural networks in machine learning. Neural networks borrow heavily from our understanding of the biological brain. They consist of interconnected nodes or neurons. Each neuron receives inputs, processes them, and sends the output to other neurons, much like our brain cells do. The strength of these connections, or weights, can be adjusted based on the learning process, enabling the network to adapt and learn over time. But neural networks aren't just a mere imitation of the human brain. They are a simplified mathematical model that captures the essence of how a brain learns without getting entangled in the biological complexities. They can handle vast amounts of data, identify patterns, make predictions, and continuously learn from their mistakes. What's more fascinating is that neural networks can be deep, with multiple layers of neurons between the input and output. This depth allows them to learn complex patterns in the data, a feature that's been instrumental in breakthroughs in image recognition, natural language processing, and other domains. However, it's essential to remember that neural networks, like any tool, are not infallible. They require careful design, appropriate training data, and constant monitoring to ensure they function optimally. And while they mimic aspects of human cognition, they don't possess consciousness or emotions. In essence, neural networks have brought us a step closer to creating machines that learn, adapt, and solve problems like humans do. They've opened up new possibilities in machine learning, pushing the boundaries of what machines can achieve. They're a testament to the power of human ingenuity, transforming our understanding of learning and intelligence. Neural networks enable machines to mimic human thought processes, and in doing so, they've proven to be a powerful tool in the evolution of machine learning and artificial intelligence. How does an ocean of data fuel machine learning? Picture driving a car. The more roads you travel, the more experiences you gather, and the better a driver you become. In the world of machine learning, the roadways are data, and the car is a learning algorithm. Big data is the term we use to describe data sets that are so vast and complex that they defy traditional data processing applications. We're talking about terabytes, petabytes, even exabytes of information. But why is this ocean of data so vital to machine learning? Well, the answer lies in the pattern recognition capabilities of machine learning algorithms. Machine learning is all about learning from experience. The more data an algorithm is exposed to, the better it becomes at understanding patterns and making predictions. It's like a child learning a language. The more words and sentences they hear, the better they become at understanding and speaking the language. Imagine you're trying to teach a machine learning model to recognize images of cats. If you only provide it with a few dozen photos, it might struggle. But if you feed it with millions of images, each showing cats in different positions, lighting conditions and backgrounds, the model will eventually learn to distinguish a cat from any other object. This is the magic of big data. It enables complex learning. It allows machine learning models to understand the subtleties and nuances that would otherwise be impossible to grasp with smaller datasets. It's like giving a painter a larger canvas and more colors to work with. The result is a richer, more detailed picture. But big data is not just about quantity. It's also about diversity. The more varied the data, the more robust the model. A model trained on a diverse dataset can handle a wider range of scenarios and make more accurate predictions. So, in essence, big data provides the raw material for machine learning algorithms to learn, grow, and improve. It's the fuel that powers the engine, the food that nourishes the brain, the roads that guide the journey of learning. Big data is the fuel that powers machine learning. What does the future hold for machine learning? Just like the human mind, the realm of machine learning is in a constant state of evolution and growth. As we push the boundaries of artificial intelligence, we're opening up a whole new world of possibilities. So, what can we expect from the future of machine learning? To begin with, let's explore how machine learning could transform healthcare. With its ability to analyze vast amounts of data quickly and accurately, machine learning could help doctors diagnose diseases earlier and more accurately. Imagine a world where machine learning algorithms can analyze medical images or genomic data, identifying subtle patterns that human eyes might miss. This could lead to earlier intervention, better treatment plans, and ultimately, better patient outcomes. In the financial sector, machine learning can help analyze market trends, predict stock movements, and even detect fraudulent transactions. This could lead to more efficient financial systems and safer transactions for everyone involved. The days of poring over endless spreadsheets could be numbered, replaced by a future where machine learning algorithms do the heavy lifting. The transportation industry is another sector where machine learning could make a significant impact. Self-driving cars, powered by machine learning algorithms, could revolutionize the way we travel. These vehicles could potentially reduce traffic congestion, improve road safety, and provide a more efficient and comfortable travel experience. But it's not just these sectors. Machine learning has the potential to touch every aspect of our lives, from the way we work to the way we play. It's a future where data-driven decisions replace gut instincts, where predictive analytics help us navigate our world, and where machine learning algorithms help us solve problems we didn't even know we had. So, as we look ahead, it's clear that the future of machine learning is bright, filled with potential and promise. It's a future where machine learning is no longer a buzzword, but a reality that's intertwined with our daily lives. The future of machine learning promises to revolutionize our world. With great power comes great responsibility, right? It's a phrase we've often heard, and it rings especially true when we delve into the ethical implications of machine learning. Machine learning, as we've learned, is a powerful tool. It has the potential to revolutionize industries, streamline operations, and even save lives. But like any tool, it can be misused. In the wrong hands, machine learning can be used to discriminate, to manipulate, to invade privacy, and even to wage war. Let's consider bias. Machine learning algorithms are only as good as the data they are trained on. If that data is biased, then the algorithm will be too. This can lead to discriminatory practices, where certain groups are unfairly targeted or overlooked. It's up to us, the creators and users of these algorithms, to ensure that our data is as unbiased and representative as possible. Then there's the issue of transparency. Machine learning can be a black box, with complex algorithms making decisions that even their creators don't fully understand. This lack of transparency can make it difficult to hold people accountable for the actions of their algorithms. It's crucial that we strive for transparency in our algorithms to ensure that they're making fair and just decisions. And let's not forget privacy. In a world where data is the new oil, privacy is a major concern. Machine learning algorithms can potentially access and analyze vast amounts of personal data, which can be exploited if not properly protected. It's our duty to safeguard this data and respect the privacy of those it belongs to. In the end, it all comes down to responsibility. We, as developers and researchers, have a responsibility to develop and use machine learning in a way that is ethical, fair, and transparent. We need to consider the potential consequences of our work and strive to minimize any negative impact. As we harness the power of machine learning, we must also navigate its ethical landscape. We must remember that our actions today will shape the world of tomorrow. Let's make sure that we shape it for the better. So, are we ready to embrace the AI revolution? As we have journeyed together through the complex world of machine learning and artificial intelligence, we have discovered the intricate intersection between the two, demystified the concept of machine learning, and delved deep into its different types: supervised, unsupervised, and reinforcement learning. We've seen the power of neural networks and recognized the pivotal role of big data. We've gazed into the future of machine learning and pondered the ethical implications of AI. Let's take a moment to reflect on these key points. Machine learning, a subset of AI, is all about enabling machines to learn from data and make predictions or decisions without being explicitly programmed. The types of machine learning, supervised, unsupervised, and reinforcement learning, each have their unique approach and application. Neural networks mimic the human brain in processing and interpreting information. Big data is the fuel that powers AI and machine learning, providing the vast amounts of data necessary for training algorithms. Looking ahead, the future of machine learning promises advancements that will transform every aspect of our lives, from healthcare to transportation to entertainment and beyond. Machine learning is set to revolutionize our world. Yet, as we usher in this new era, we must also grapple with the ethical implications of AI. Questions about privacy, bias, job displacement, and more must be part of the conversation as we move forward. The AI revolution is not a distant future, it's happening right now. And it's not just for AI researchers or tech enthusiasts, it's for everyone. Whether you're a student, a professional, an artist, a parent, or simply a curious mind, there's a place for you in this revolution. I encourage you to learn more, to ask questions, to explore, and to engage with AI and machine learning. As we stand on the brink of the AI revolution, the possibilities are endless. Embrace it because this revolution will shape our future.